All right, hello everyone. We're going to look at lesson 17, which is the periodic trends. And you'll want to have lesson 17 slides. You'll also want to go and open the periodic table. And then, of course, you'll be looking at the actual assignment. So I'm going to discuss each trend, and then I'll let you try the problems, and then I'll go over the problems. So we have 4 trends we're going to discuss, so this will be cut up into 4 pieces. So the first trend is the atomic radii. For each of these trends, make sure you understand what the trend is describing, and then understand how to compare atoms within the trend. So atomic radii is the distance from the center of the atom to the outermost electron, or the electron that's furthest away. So this really just measures the size of the atom. So I want you to think, do you think atoms get bigger or smaller as you go to the right on the periodic table? And then do you think they get bigger or smaller as you go down the periodic table? Okay, now, as they go down, they get bigger. I mean, you look at the weights, the mass is all increasing. The big thing, though, is as you go down, you end up with higher energy levels. So it's like adding a whole ring of electrons to the atom. Here's what seems weird at first, but makes a lot of sense when you understand it. As you move to the right, yes, you see the masses getting larger. So you might think, I'm going to guess the atoms get larger, but that's actually not what happens. As you move to the right, you end up with more protons. Notice this has 22 protons. This has 23 protons. This has 24 protons. And since the protons are in the middle of the atom, protons are positive, the negative electrons on the outside are drawn towards the positive proton. So adding more protons to the atom pulls all your electrons towards the center, making the atom actually smaller. Even though it has more stuff inside of it, so it has more mass, it's going to take up less space and be smaller. So when it comes to atomic radii, what's going to happen is as you go, your atomic number gets bigger, the atomic radii is going to get smaller. So actually moving to the right makes your atom smaller. But then, as I said, moving down will make the atom larger. So the atomic radii increases as you go down into the left, meaning that if you want to figure out which elements are large, the further they are down and the further they are to the left, the larger their atomic radii. So that basically would mean that francium would be the largest as far as the amount of space, the atomic radii is going to be largest for francium, and it's going to be the smallest for helium. So with that in mind, I want you to try the first 3 problems. So try 1, 2, and 3. Don't bother with 4. I'll explain 4. So pause it, try 1, 2, and 3, and then press play, and I'll go over it. All right, number 1, Cl and Br. So just look at where they're at. Here's chlorine, here's bromine. We're doing atomic radii. Remember, what is our trend? It's smaller as I go down into the left. So out of these, they're in the same column, but bromine is lower, and going down makes them larger. So bromine will be your correct answer for that. So this one would be bromine. Mg and F. We have Mg, we have F. Remember, down and to the left is going to be larger, so magnesium is your answer there. And then number 3, cesium and chlorine. Chlorine is Cl right here. Cesium is right here, Cs. Down and to the left is larger. So for this one, my answer will be cesium. Okay, this one, I think it might be opposite of what you think. What do you think is going to be bigger? A plain atom, an atom with a positive charge, or an atom with a negative charge? You might think positive sounds like it would be bigger, but that's actually the opposite of how it works. If an ion or an atom is a cation, meaning it has a positive charge, you cannot gain or lose protons and be the same element. So positive charge, that actually means you've lost electrons, which will make it smaller. Negative charge means you've gained electrons. So go ahead and answer number 4. Which of these is going to be the largest? A normal chlorine, Cl with a negative charge, Cl with a positive charge. I hope your answer would be that chlorine with the negative charge is larger because it's gained an electron. Okay, next trend, ionization energy. Now, ionization energy, this basically is how much energy it takes to pull an electron out of the element or the atom. So how much energy does it take to remove an electron? So the more energy it takes, we're saying that means it's harder to remove an electron. Let's think about what we learned with atomic radius. Which ones are going to be the largest? Down in the bottom left. What that means is that their electrons are really far from the protons. And didn't we talk about how electrons are negative, protons are positive? So there's an attractive force there. So what do you think is going to be easier to do? Remove an electron way far away from your positive nucleus, or remove one that's super close to your positive nucleus? Well, it's going to be way easier to remove it when it's further away. So basically, if atomic radii is bigger down and to the left, then the ability to remove electrons, or the ionization energy, we're going to have the opposite trend. So that's going to be, so it's going to take more energy as we go up and to the right to remove electrons. So your trend for ionization energy is up and to the right. So when we do these same kind of questions, you'll notice right now that 5, 6, and 7 are the same as 1, 2, and 3. Cl and Br. Which one's going to have the higher ionization energy? Let's look at Cl and Br. Now we need to do whichever one is up and to the right, whichever one is highest. Okay? So we'll do Cl for that one. Cl is going to win. I'm sorry. I said I would pause, let you try them. So press pause, try to do 6 and 7, and then I'll go over them. Okay, so magnesium and fluorine. Fluorine upper right, magnesium down and to the left. Since we are doing ionization energy, the one that's further up and to the right. So fluorine is going to be our answer. And then which one has the highest between Cs and Cl? Cs way down here in the bottom left, Cl way over here in the upper right. So our answer here is going to be fluorine, Cl. Okay, now we're going to do electron affinity. Now electron affinity is a little bit weird. Electron affinity is how much energy it takes to add an electron to an atom. And so what's going to happen, it's going to increase as we go from left to right. So the energy, what's going to happen is the energy that we have to, that's required to add an electron, it's going to increase as you go to the right. But here's the exception. 2, 12, and 18 are the exception, meaning these will always have the lowest electron affinity. In fact, group 18 has electron affinity of almost 0. So I know our trend says it increases as you go to the right. The exception, like I said, is group 2 right here, group 12, and group 18. And that's because these guys are basically like having S2 and D10 and P6. Their sublevel is full. In fact, with this one, this is almost 0 because you have a full shell of valence electrons. It has no electron affinity because you can't add an electron to it. It just won't take one. So it's like it doesn't even happen. So your trend will be whichever one is furthest to the right, you'll say is highest, unless it's in 2, 12, or 18, then it's just automatically the lowest. Okay, so with that, I want you to try to do 8, 9, and 10. And then, so press pause, do 8, 9, and 10, and then press play, and I'll go over it. Okay, F and E. Fluorine and neon. Here's fluorine, here's neon. The trend is to the right, is going to have a higher electron affinity. However, if you're in 18, you're actually going to be the lowest. So F will have the highest. So for that one, you would answer F. So for number 8, your answer should be F. Number 9, Na and Mg. So we have Na and Mg. Remember, to the right is supposed to be higher unless you're in 2, 12, or 18, then it's the lowest. So Na is actually going to be the highest right now. So Na is going to be our answer here. And then let's do gallium and zinc. So Ga and Zn, which one was going to have the highest electron affinity? So here's gallium, here's zinc. Gallium is more to the right. Gallium's not in 2, 12, or 18, so we'll go with gallium. So that'll be our answer there. All right, last trend, and then we're done. Last trend is electronegativity, and this is a measure of the atom's attraction between the nucleus and valence electron. So think about it. If the nucleus full of protons is closer to the electron, it's going to have a stronger attraction. Kind of like when you have magnets, it's harder to pull them apart the closer they are together. So since we discussed that up here is going to be the smaller atomic radius, down here is going to be the larger, that means up here we have a much stronger attractive force. So the trend for electronegativity, it increases as you go up and to the right. So I want you to do these next 3. Press pause, go over these 3, and then I'll do them. Okay, so Cl and Br. once again, we're doing up and to the right is highest. So Cl is going to be our winner there. Mg and F. Once again, up and to the right is going to win. So Mg is over here, F up and to the right. So for this one, fluorine will be our winner. And then Cs and Cl. Cs way down bottom left, chlorine way up in the upper right. So the trend is up and to the right, so chlorine's going to win there. So in summary of everything, we have atomic radii, which is going to be highest down and to the left. We have ionization energy, which is highest up and to the right. We have electron affinity, which increases to the right, except for 2, 12, and 18 will be the lowest. And then we have electronegativity, which increases up and to the right. So as always, email me if you have any questions. And hopefully you don't have too hard a time with this.